ସେଠୁ ସେଠୁ
हेलो शुभुजी
ସେଠୁ ଶୁଭୁଛି
हाँ शुभुजी मो कथा शुभुजी
ଶୁଭୁଛି ସ୍ଲୋ ହେଇକି ଶୁଭୁଛି ଆଉ
मो कथा शुभुजी मते शुभुजी
ଆଁ କଣ କହିଲୁ କଣ କହୁଛୁ ହ୍ୟାଲୋ
हाँ हेलो
ହଁ ଶୁଭିଲା
ସେତେବେଳେ
ଭଲକିରି ଶୁଭିଲା
ଶୁଭୁନଥିଲା
ନାଇଁ ଆଉ
मोर आरटाକୁ ବି ଲଗଇନ୍ କରନ୍ତୁ
ଇଏଟା
ନନ୍ଦନ ସାର୍
କଟା ଲଗେଇଦେ କଣ କହିଲୁ
ନନ୍ଦ ସାର୍
ଟିକେ ଫ୍ଲକ୍ଚୁଏସନ ହଉଛି ରେ
हाँ सर
ହଁ ହଁ ସରୋଜ ସାର୍ ବି
ନନ୍ଦ
ଆସିଲେ
ସାର୍ मोर आरटा ଆସୁଛି ଆର ସିଷ୍ଟମ ଟା
आसुनी तो
ସାର୍ ଟିକେ କହିଲେ
ମୋର
ଜଏନ୍
ଟାସ୍କ
ହେଇଯିବେ
ଲିଷ୍ଟ ଲେଖୁଛି
ଟାଇମ୍ ହଁ
नहीं आसुनी
ଆଚ୍ଛା ଠିକ ଅଛି ମୁଁ
ଓହୋ
ଦେଖୁଛି
ଓ ଆସିଲେ ଯିବେ ଏବେ ଆଚ୍ଛା
आसुची
ଆଚ୍ଛା
आसुची
ହଁ
ठीक है
ହଉ ଆଉ କୁହ ହଁ ହଁ ହଁ
नहीं आसुनी तो
ହଁ ଆଚ୍ଛା ଆଚ୍ଛା ହଁ ଠିକ ଅଛି ଇଏ ଚାର୍ଜ ପକା ସେଠୁ
हाँ भाई ना को
ଇଏ ଆମ ଲ୍ୟାପଟପ୍ ଟା କାହିଁକିରେ ଆଉ ସେଇ ଇଏ ୱାଇଫାଇ ବଟନ ଟା ଆସୁନି ଏ ଯୋଉ ଆଜି ସକାଳେ ହେଇଗଲା ଅପଡେଟେଡ
तो
ହଁ ହ୍ୟାଲୋ
तुम कथाटा दी थर कहीं दीटा मोबाइल रखा लगा कि
ଦିଟା ମୋବାଇଲ ପାଖରେ ଅଛି ହଁ ହଁ ଦିଟା ଅଛି
ନାଇଁ ଗୋଟେ କରେ କର
ନାଇଁ ଗୋଟାକରେ କରୁଛି ତ ଗୋଟା ଖାଲି ଥୋଇଛି ଗୋଟାରୁ ଖାଲି ୱାଇଫାଇ ଆଣିଛି ନା ଏବେ ମୋବାଇଲ ରେ ନାହିଁ ଇଏରେ କରୁଛି ହଁ ରହ ଟିକେ ହ୍ୟାଲୋ ହଁ ହଁ ଏଁ ହଁ ହଉ ସାର ଆସିବେ ମଝିରେ ଆଚ୍ଛା ଆଚ୍ଛା ହଁ ହଉ ଆଉ ହଉ ଠିକ ଅଛି ହଁ ହଉ ରଖୁଛି ତାହେଲେ ଇଏ ଏମଏଲଏ କହିଲେ ସେ ମଝିରେ ଆସିକି ଜଏନ ହେବେ कंटिन्यू करवा।
हाँ स्टार्ट कर।
नंदू सर एटा कहीं मोर आसुनी।
मोर कथा सुबुनी कि ताकू। हेलो everyone can see and hear you. You are in the show. लिखिला दे एटा कोन दे
लिखि जे तो देखो जेटा माइक अछि कैमरा अछि।
हेलो
हाँ है ना।
नहीं लो बेटी
मैंने स्टार्ट कर
से तो सारे आसिलेनी प्रिंसिपल आसिलेनी ठीक है ताको ऑन कर दे।
करजिबा सी एबे कटि गले
प्रिंसिपल स्टार्ट करिवा की।
हाँ हाँ
हेलो हेलो
हेलो एवरीबॉडी
हेलो
it is a cheerful lovely Friday morning on behalf of Department of Physics BS College Daspala. I myself Dr. Umakant Tripathi from my side warm welcome and good morning to you all for your participation.
एटी अछि सिद्धार्थ आसिला
Heartiest welcome to our honorable guests, teachers, students, physics loving friends, and all others present here in this webinar. Internet of Things and Dampers in Electrical Circuit. Conducted by Department of Physics, BS College Daspala. Our college is a leading college in Western Odisha and second oldest college in Noyagad district. It is a NAAC accredited college rolling with science and art stream. Students are reading here with a clean, green and homely environment. So many so many UGC approved national seminars have been conducted. But this NWID 2020 is the first webinar of our college. We will take a minute to introduce our esteemed galaxy of guests, which are extempo and expert in all respects. Heartiest welcome to our beloved guest for today, Mr. Ramesh Chandra Behera, Honorable MLA Daspala. He is well recognized in his locality for his smiling face. People worship the ground where he works. He is not that he is a politician. He is a very good academic, educationalist, and administrator. Morning shows the day. He had started his practice in Komaresai Daspala High School, at NSC High School, Noyagad, and a graduation at Noyagad Autonomous College. He is very academician. He got his prestigious MPhil award from JNU New Delhi. He has a good from his childhood. I am telling this from my experience because we were in the same hostel in our graduation career. Now, now I need not require to explain him. He was the son of soil, but now he is the Sardar of soil, who believes in words, not in words. So we are very much fortunate to have our beloved MLA with us to sir to this webinar. Now I welcome to the speaker for this first session, Dr. Saroj Kumar Das, who is working now in a senior assistant professor in Vellore Institute of Technology, one of the best private university in the field of technology in India. He got his prestigious NBSW fellowship to pursue his PhD in Institute of Mathematics and Applied Applications abroad. And also he got the postdoctoral degree in IIT Madras. Our beloved speaker is not only interested in mathematics but also in physics. In physics, he has a deep knowledge in mechanics, quantum mechanics, and so on. So we appreciate your golden presence, sir, in this webinar with us for today. Our guest for the second session, Dr. Umakanta Nanda. He is a good educationalist. He got his PhD as well as his MTech in MTech Raurkela and went abroad for his research. We all are astonished that he has made 30 research papers published in reputed journals in such a young age. And it is a very astonished fact that this speaker, Dr. Nanda, has published 3 patents under his name. In this country, no state behind where he had not given his talk to the research scholars. His field is in electronics and its applied branches. In IBM, we have had that the production of this ICs. Only there are 300 engineers are working for the manufacturer. Only 5 are for their testing, and your speaker for today is one of them. So I again welcome you, sir, for this webinar. Our house, all the efforts are on our parents. For the total webinar will not be gone through without the effort of the great soul, the dynamic personality, none other than our principal, Professor Sridhar Ratha sir. His guidance made this department encouraged, and without which it is in a blind. The webinar will not be existence. So I welcome Professor Sridhar Ratha sir, our principal, to this webinar. And rest BK Amarendra sir, the faculty of Department of Physics. His activeness and technical support leads this webinar to this position. So I also welcome you, sir, to this webinar. Now, I request our principal sir, Professor Sridhar Ratha sir, to give some inaugural speech. Principal
Hello,
sir.
everybody. Hello, everybody. Welcome. Good morning. Is it audible? Is it
Yes,
audible,
sir.
sir?
Yes, sir.
Good morning, sir.
Hearty welcome to you all, the members, the community, to this physics department on the occasion of the webinar organized by our college physics department. The members in the occasion, Professor Saroj Kumar Das, Associate Professor, Assistant Professor of VIT Chennai, Tamil Nadu. Professor Umakant Nanda, Associate Professor of VIT Andhra Pradesh University, Vijayawada, Andhra Pradesh. Professor Umakant Tripathi, Dr. Umakant Tripathi, the HOD Physics Department of BS College, Daspala. Our beloved Dr. Amarendra, B.K. Amarendra, the lecturer in physics of our college. All other dignitaries, members present in this occasion. Hearty welcome to you all on the auspicious occasion. Because we are in COVID position, we are now under video conferencing. Otherwise, we could have arranged a better move in our college. Now, the departmental subject matter, as explained by our Professor Umakanta Tripathi, leads to Internet of Things and it dampers the electrical circuit. He will also go through the subject. There will be a greater allocation, analysis of this subject matter. I am being the principal of this institution. I am very much thankful to you all that you have cooperated and you have participated in the meeting through the designated mail so that we will be obliged to you all. Now, our MLA will join. He is a very loyalty person, anxious to these meetings. He was also interested and he will deliver his speech on his arrival to this meeting, on his joining. Now I welcome the members and I am very much hopeful that it will have a greater discussion on the subject matter as designed by Professor Umakanta Tripathi. Wishing you all a good day. I remain the principal of this college and hope that meeting will be a success through video conference. Thank you all. Now Mr. Tripathi will continue the meeting as well, as per the agenda. Mr.
Thank you,
Tripathi.
sir. Thank you, sir, for your
Yes.
nice speech. This will encourage us, and we will encourage to arrange such seminars in for near future. Thank you again, sir.
Thank
Mute alagi. Hello,
Hello.
Yes, sir, you are audible.
am I audible, sir?
Yes, sir,
Yes, sir.
audible.
Thank you, sir, for your nice speech. It will give us more encouragement to arrange such type of webinar in your future. Again, thank you, sir. Our guest for the today, Dr. Ramesh Chandra Behra, MLA, has some personal problem. He gave us word that he will join in the midway of our seminar. So I now request our speaker for the first session, Dr. Saroj Kumar Das, to continue his speech and gives the presentation for our audience. Saroj sir, please.
Thank you. Thank you, Principal Sir. Thank you, the organizers of BS College Daspala, to give me this opportunity to talk my favorite topic, which actually very much. So, am I audible, sir?
Yes, sir, audible.
There
Continue.
is some network problem.
Okay. No, my voice is breaking. Is my voice
No,
breaking?
it is fine.
Okay, fine. So, so let us start our discussion. The first topic, actually, it is about the spring mass system and RLC circuit. So let me go for the presentation. Nanda sir, you can means you can switch me off this where I am talking now, because it will.
So now, okay. So am I audible now? Nanda sir?
Yes, sir. Audible, audible.
Okay, thank you. I switched off my camera camera laptop because it gives a disturbance. Okay. Okay, so this is, I'll run few videos first. Let me see. Okay, how many participants are there, and mainly who all are the participants? Means what is the level of participation? All are students or some teachers? Any idea? Nanda sir?
Teachers are there. Teachers are there.
Okay, maximum teachers are there.
Ah, sir.
Okay. Okay, thank you, sir. Okay, so anyway, so usually we are teaching to engineers. Means I used to show some video. Initially, means some initial things. I used to show some video. Then only I was starting my lecture. Okay. Yeah. Okay.
Sarosh sir, please share your screen.
Yeah, I'm sharing. Just 1 minute. Give me 1 minute. I'm sharing.
ମାଇକ୍ ଅଫ୍ କରିଦିଅ।
ଉମାକାନ୍ତ ନନ୍ଦ କହୁଛି ଯେ ସରୋଜ ସାର୍ କୁଆଡ଼େ ଗଲେ ତା ସ୍କ୍ରିନ୍ଟା ଆସୁନି।
Sir, I am here only. I'm sharing. Okay. Okay. So actually, principal sir, this the presentation laptop, I have some problem with my camera. So here you cannot see me, but because I want to write something, that's why I am switching to this laptop. The other laptop had a camera, but now it is I switched off.
Okay.
Okay, sir. Thank you, sir. Okay, so I am sharing my screen.
এটা বড় স্ক্রিন କରି ହେବ ନା ଆସନ୍ତା ବଡ ଏଇଟା ୟୁଟ୍ୟୁବ ଯୋଗୁ ଛୋଟିଆ ନାହିଁ।
Okay, sir. So now,
ହଁ ଆସିଲୁଣି।
so this screen is visible to all.
ଭଲ ଅଛନ୍ତି ଭଲ।
Yes, sir. Visible.
Okay, thank you. So mainly we are going to discuss the topic, the title I want to discuss, that is the spring mass system. So it is very useful topic for everybody, including scientists, engineers. It is very basic to understand, and if somebody can understand this, how it is working, then means many many things can be clear for them. Okay. So for that reason, okay. So you know that. So if I make one picture, so if I have one spring, so it maybe have some length. Suppose the length of the spring is capital L, and if we attach one mass, then it will be elongated, and so mass is attached here, and it is in equilibrium position. After stretching, say small L, it will be in the equilibrium position. Now, if we apply one external force to it, it will become one vibration. It will start its vibration up and down, and that vibration, suppose we displace this displacement is, suppose with the time it will change. That's why it is a function of time. So it can be go, means it can come down, it can go up. So it is a very simple model, but if you see almost every physical system like bike, even cycles, cars, everything has this spring mass system, means everything obey this spring mass system. It is very crude, means we have to generalize it, and if we go for generalization it will be very complicated. If we don't have any idea how to tackle this one spring one mass system, then multi-mass multi-spring system will be very difficult model. So because of that, we have to start here. Maybe after giving the equation, I'll show you some video. So we know that the total force acting on this mass spring system, if that is so the total by Newton's second law, we know by Newton's second law of motion, the total force will be m into the acceleration, mass into acceleration, mass into the acceleration. So that is the standard thing we know in plus 2 physics itself, or even in high school nowadays. The total force is mass into acceleration. But because a lot of constants involved here, okay, so maybe for the whole thing, okay, let me put this is my external force acting on this body, and also we have kept this body or this mass inside one medium, okay, inside one cylinder. Okay, let me show you one small video, and maybe later I will show you again the same thing. So is it visible? Is this screen visible? Is this screen visible, sir?
Yes, yes, sir.
Okay,
Yes,
thank
sir.
you. So it is means the mass spring system is like this. Okay, so I will come back to this video again once I'll explain the topic. Is it okay, sir? Tripathi, sir? Is it okay? Okay.
Yes, sir.
Now
It is
the way I
visible.
am presenting, is it okay, or you need something changed?
No. It is pure
Okay,
perfect.
fine. So the total force is mass into acceleration, and you know that so acceleration in terms of displacement, I can write that as, if mass is m, then I can write this as m d2x by dt square. If anybody has seen the calculus, they might have seen this term. Acceleration is the double differentiation of displacement. Acceleration is a differentiation of means rate of change of velocity with respect to time. So the velocity is rate of change of displacement, and hence it is double derivative of the displacement. Okay, so this is our equation 1. Now the other forces acting on this system is like okay, so it is when it is on the this position, it is actually on the neutral position or the equilibrium position. So when it is in equilibrium position, the weight always acting on means uh, the what is that? So the first force will be F1 will be the weight of this system, and that is nothing but our mg. Okay, that is our first force acting on this system. So this is our total force. This is the first force, and the other forces are like F2 will be the restoring force, because spring is attached to this. The restoring force acting on this. So once the body is on the motion, so when it will come down, the spring will try to pull it up. When when it is going up, the spring will push it down. So that is the way. If a body is moving downwards, the spring will try to pull it up. If body is going up, it will push it down. So that's why the restoring force is always negative. It's negative always, because it is opposite to the motion of the body. It's negative always. Okay. So what are the restoring force? We know that by Hooke's law, the restoring force is directly proportional to the displacement, and here displacement is xt. So that means we can write that as F2 is equal to um okay okay. So displacement actually xt plus, so we have to add this length also. So it will be so as I have told, it is negative always. So it will be minus okay k times x plus l. Okay, I am not writing this t always. It is well understood. X is a function of t. Okay, so we know that at equilibrium position, that is t equal to 0, our F2 is same as mg, because it is negatively applied, so it is minus mg equal to minus k into so at equilibrium position t equal to 0 means x of 0 is 0. Okay, so this is 0 plus l. So that means minus mg is equal to minus kl. Okay. Sir, if any difficulty, please let me know so that I can change myself. Okay. Now, because this spring mass system is inside one medium, so So that viscous medium, you know that even air has also the density. We can neglect sometime, many times we are neglecting, but if we will not neglect the medium, so the medium will give us F3, and this F3 is due to the resisting force called the resisting force of the medium. So medium can be anything. It can be water, it can be any other liquid, it can be even air. Air will have negligible resistance. That's that time we can take 0, but it may not be true always. So only vacuum will have the resistance will be 0. If we do any experiment in vacuum, then only we can consider F3 is 0. Otherwise, we cannot consider that is 0. So this is called the damping force. This is also called the damping force. I'll show you some video how the damping is coming to our everyday life. Okay. So we know that by physics law, so this damping force is directly proportional to the velocity of the system. So it is directly proportional to the velocity. So we know that. So this implies F3 is equal to, I can write some damping constant B times the velocity. We can write that as dx by dt. If x is the displacement, then velocity we can write that as dx by dt. And again, because it is also opposing the force, opposing the motion, it will be always negative. Okay, so F3 is also negative. So we have all these 3 forces acting on the system, and the fourth force, that is the external force, if at all is there, external force acting on the body. If external force is 0, then we will see that what is the how the spring mass system is working. And if external force is non-zero, so let us consider this as our f of t. So it can be any function. It can be any function of t. So that is our external force. So external force also sometimes called forced. Okay. Okay. Anyway, so we can see that. So it is easy to check. The total force will be, the total force acting on this system will be equal to, by Newton's law, second law, the total force by Newton's law will be m d2x by dt square. That is the total force acting on the body, and that will be same as F1 plus F2 plus F3 plus F4. And F1 we have seen that is mg. F2 we have seen that is minus kx minus mg. If you see the above equation, you can easily notice F3 will be minus what is that, minus b dx by dt, and F4 is our f of t. So if we rewrite this equation, so okay, this mg and this minus mg will cancel out. So if we rewrite this equation, then it will be m d2x by dt square. So if I take this minus term this side, it will be b times dx by dt plus kx equal to f of t. And for simplification, let us write this as d2 x by dt square plus d by m dx by dt plus k by m x equal to f of t. So this is the governing equation for the spring mass system. So we know that mass cannot be zero. So mass cannot be zero. That's why we can always write the equation, the governing equation in this form. Okay. And you know that uh, Tripathi sir, okay. So shall I go for the detailed calculation? How you are getting the solution, or shall I give only the formula?
Sir, please calculate it.
Okay, okay, fine. Not an issue. So let us consider this is our the governing equation 1. So we means somewhere you might have studied. If you have not studied, maybe somewhere you will study this. Such type of differential equation we usually solve by. So usually we are solving this as, so to get a solution, or to get the solution of 1, we need to solve the first part is the homogeneous equation. That means I have to consider, let us consider there is no external force. So that is no external force. Means external force means action will come little later. First we have to find if there is no external force, how the system behaves. Okay. So okay, that means f of t is 0. Okay. So and the second part is, so this is first part. The second part is, after getting the homogeneous solution, after solving the homogeneous equation, we will find one particular solution, for the equation, for the ordinary differential equation. Tripathi sir, please let me know how much time I will have, because I have to skip many things otherwise.
You have 20 minutes left.
Okay, another 20 minutes I have, correct? Okay.
Yes, sir.
So to solve the first part, means the homogeneous part, so the first step, the homogeneous equation, if you see the whole equation, I can rewrite this as x double dash plus some constant. Let me write, suppose, okay, let me write this, whatever it is written, b by m x dash. So I am representing dx by dt as x dash. So d2x by dt square will be x double dash. Some books you may find a dot, but anyway, all are same if we are getting solution. Okay, so this is k by m x equal to 0, because we have considered there is no external force at the initial state, means at the beginning. So first, to solve this, we have to rewrite the characteristic equation. Therefore, the characteristic equation how we are getting this characteristic equation? Again, we are considering, suppose exponential function is a solution for this homogeneous equation. So we are getting one characteristic equation, the corresponding characteristic equation, the corresponding. Little detail you may study in your course. The corresponding characteristic equation will be lambda square plus b by m lambda plus k by m equal to 0. And if we, so this is your quadratic equation. So if we try to get the solution of this quadratic equation, you know that the quadratic equation will have solution, that is minus b by m plus or minus square root of b by m whole square minus 4. The coefficient of lambda square is 1, so that is 4 into 1 into k by m whole divided by 2. So this is means you might have studied in your school. So quadratic equation solution can be written always like this. So if we simplify this, it will be minus b by 2m plus or minus 1 by 2m square root of b square minus 4mk. Okay. So this is for various values of b, m and k, these values will change. So we know that square root of positive number is always a positive number, and square root of negative number is an imaginary number, is a complex number. So so that is the case. So case 1 we have to consider, that is if b square minus 4mk is strictly greater than 0. So in that case, we'll write lambda 1 as minus b by 2m plus 1 by 2m square root of b square minus 4mk. When it is plus, I am writing that it's lambda 1 and lambda 2 as minus b by 2m minus 1 by 2m square root of b square minus 4mk. Okay. So hence the general solution of this homogeneous equation, let us consider this is 2. So the general solution of 2 is ext equal to some arbitrary constant c1. We know that the general solution always will have the arbitrary constant, will involve the arbitrary constant. Okay, I can put any constant, any value for c1 and c2, it will satisfy the equation. So this is our general solution for the homogeneous equation. And let me first cover all the cases, then I'll come back to the external force term with external force term. So again, case 2 will be if b square minus 4mk is equal to 0. So that means this particular term will not be there. So square root also will be 0. So implies lambda will be only the term minus b by 2m. So there is no lambda 1 and lambda 2. Both are same, and that is minus b by 2m. So in that case, the general solution, that is again you will study more when you will study the course. So you can notice here. So how we are writing? So c1. So the solution will be, one solution will be c1 e to the power lambda t, and another solution will be c2 e to the power lambda t. So how this t is coming, that you will study maybe during the course. So we can rewrite this as c1 plus c2t e to the power lambda t. Okay. Now case 3. So we know that if b square minus 4mk is negative, so implies we will have so lambda 1 we can write that as alpha plus I beta, and lambda 2 I can write that as alpha minus I beta, where alpha will be equal to minus b by 2m and beta will be equal to square root of 4mk minus b square, because b square minus 4mk is negative, so 4mk minus b square is positive, so beta is this square root of this. And the general solution, again I am writing the solution directly, therefore the general solution xt is equal to okay, e to the power alpha p plus into c1 cos beta t plus c2 sin beta t. So how this cos and sin terms are coming here, maybe you'll study, means from this Euler's equation you can get it. So we can write that as e to the power lambda 1 t plus e to the power lambda 2 t will be the general solution. From that we will get to this. Okay, so all these three cases are there, and now I am coming to okay. Let me discuss what will happen. So if time tends to infinity, that means for a long time, if you do this experiment, then how the displacement behaves. You can see that in case 1, the solution is e to the power lambda 1 t plus e to the power lambda 2 t. Arbitrary constant are only numbers. It will not have any effect, any major effect if we change the time. Okay, so for all c1 and c2 it is true. So now you can see that this term is positive, so there is nothing here. So this is negative term. Okay, b and m always positive terms. Okay. One thing I must tell here, so a special case I can tell here, if b is equal to 0, then the equation become x double dash plus k by mx equal to 0. Hence, okay, so the auxiliary equations will be, because b is 0, the roots of characteristic equation will be this term will be 0, this term will be 0, and this is always negative. So if you see, this is always negative. So that means this is the third case. So implies our solution will be always e to the means cos beta t plus sin beta t. We'll see that how the motion means if time even time goes to infinity, this term will never go to infinity. This is bounded term, so cos and sin never goes to infinity. So it will oscillate, and we'll see that in our video. So this is special case. This is called on damp. So no damping is there. Okay. And case 1, you can see that. Okay, I was discussing. So this term is always positive. Okay, this term is always positive. This is negative. This is also negative. So this term negative, this term negative, everything is negative. Now, what about this? So we know that b square minus 4mk is b square minus 4mk is always less than b square because it is positive. Okay, because it is positive, so it is always less than b square, because 4m is a positive, k is positive, so something I am subtracting, so it is always less than b square. Implies the square root b square minus 4mk is always less than b. So that means, so you can see that the numerator is this, denominator is same. So this term, okay, this term. So denominator is same, numerator is minus b and this term. So because it is, this term is less than b, so minus, so this minus b is also negative. So this is negative, this is negative. So we know that e to the power, the negative power of e exponential will it goes to 0 as t tends to 0. Sorry, t tends to infinity. When time evolves, the exponential with negative power, so xt will approach to 0 when t tends to infinity. Okay, so called the term is called overdamp. Okay, so this is 1, 2, the case 2, that means case 2 is this term is 0 and lambda is fully negative. So only, so this lambda is negative, so only term the t is there. So this first term is will go to 0, but this term will have little effect. So when t equal to 0, that time only it will be touching the, means it is the crossing the real line. So it is like this. So if okay, so if I do this graph, then it will be like this, asymptote to x-axis. But this graph will be, I have to come down a little bit, then only it will approach, it will be asymptote like this. And case 3, so case 3, you can see that, so alpha is always negative, alpha is negative, okay, because b and m are positive, and beta is positive quantity. So beta is not going to 0. Beta is positive. So this term will oscillate, but anyway this term will tends to 0. So this also, so it is like, it will be like this. So oscillation, 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 and it will go to 0. Okay. So all these cases are clear for all of you, sir? Tripathi sir? Hello? Hello? Am I audible?
Yes, sir.
So this case is called critical damp, critically damp, and this is called something called under damp. Okay. Now, sir, how much time I have? Shall I move quickly? Another 5 minutes, 10 minutes? Tripathi sir?
Sir, 10 minutes, sir.
Okay, 10 minutes. Okay, fine. So, okay. So to see that when force term, external force is non-zero, if external force is non-zero, not equal to 0. So that means f of t is there. So let us consider One simple example, because it is very generalized case. If we will not take any example, because we need to find a particular solution. So always we used to write all these solutions as XH. H stands for homogeneous. Always we are writing XH as the homogeneous solution, and XP as the, so we will get one, we will evaluate a particular solution, and that is why we used to write XP. P stands for particular solution, and XP is dependent on how your external force is. If external force is containing exponential term, then it has to go some way. If it is containing sinusoidal, that means sine and cosine functions, then also we can solve. If it is other trigonometry function, then it will go other ways. If it is polynomial, then it will go other way. So let us consider first the sinusoidal, which is very very important for our study. Let f of t is some amplitude, because we know that it is mass is always divided a by m. Suppose cos omega t. So omega is, so a is our amplitude, initial amplitude of the sinusoidal wave, and omega is the initial frequency. Okay. So okay. So before discussing this external force, it is better to have the video how this uh, okay, how I was means whatever I have explained, I'm just showing here in the video.
Loss of energy in an oscillator.
So you can see that
in this video, we will be specifically focusing on damped kernel strength and the angular
okay.
frequency.
So it is so all the cases under damped.
We can need complete damped
I have discussed undamped, underdamped, critically damped, and overdamped.
and overdamped.
Okay, so all these I have already discussed. Let us not concentrate these terms. It will come little later. Okay, so you can see that. Okay, so now you see the video. So this is without any
Perfect
medium.
motion is
So
impossible
air
to
has
achieve with bringing
negligible
loss.
damping.
Over a short
That's why
period of
it
time,
is
however,
moving
the decay
up
from
and
air
down
friction
almost the same way.
negligible enough that
What we have seen in our first, that is special case when damping is zero. That means beta is in this video they have put beta as the damping medium, damping constant. So actually beta is that b by 2m. So that if that is zero, then you don't have any what is that? There is no restriction, so the vibration will be there as it is. Okay. So once it is changing to the medium,
each oscillation gradually decreases until the amplitude reaches zero.
okay. So this is
If beta is greater than omega, the system is overdamped.
okay.
In overdamped systems,
So it is high viscous liquid.
without ever oscillating.
Okay. So instead of this, let me go to another video which explain actually very nicely this. So this okay. So let me show this. You can see initially, you can see how much vibration it is happening. Okay. And but because of resistance, because of the damping, it is slowing down, and it will become rest. It is not spring mass system, but means we can model the spring mass system like this. I did not get the proper video for that. So it is like if if damping is increasing, so actually this is the iron plate behind the magnet. So magnet is here. So magnet is actually creating that motion difficult. So you can see that at the end you can see, yeah. So you can see that how this movement is. You can see it is not at all crossing the line. Again, very slow. So all these, if you see our door where automatically shutdown is there, means shutters are there, you can see the doors are coming and closing to the, okay. So this is actually the thing very practically we are using in our everyday situation. Okay, so let me, so this is our, this is everything they have discussed. Okay, so actually, instead of spending time, I wanted to tell, I wanted to show this also. So this is very nice video. You can see, and then maybe I'll discuss. Okay. So this is actually happened in 1940. Okay. This happened in 1940 in US, Washington. This bridge collapsed after vibrating like this. It has collapsed down. It is broken down. So you can see if I forward this, so after 5 minutes it will break down. You can see that. See, so here it is broken down. It is collapsed. So this happened due to the resonance. I wanted to tell what is resonance. Okay. Is it okay? Tripathi sir?
Yes, sir. Yes, sir. It is okay, sir.
Okay. So the resonance, you know that it is very, very important question in many fields. What is this? So resonance, to discuss the resonance, let us consider there is no damping. Actually, it is not possible, but if it is very near to or very negligible to the system, like this bridge, the means air resistance is very negligible for this. So that is why we can consider the damping is zero, almost zero. So then the equation become x double dash plus k by m x equal to, as I have told, if I will consider this, so it will be a by m cos omega t. Okay, amplitude and omega. So if we rewrite, so if we write k by m equal to omega 0 square, that is our, okay, if I write square root of this is omega 0 is called this is initial frequency, this is the natural frequency. Okay, so if this is a natural frequency, then if we solve this, actually I could not solve the particular solution, but anyway you will study that somewhere. The solution will be like this. It will be like C1 cos omega t plus C2 sin omega t plus this particular solution will be a by m omega square minus omega 0 square, okay, or omega 0 square minus omega square, doesn't, okay, omega 0 square minus omega square cos omega t. Okay, So this is our solution for this system. You can see that in the denominator, this term is there. So this is a valid solution. This gives us a valid solution. So this term is valid. 3 is valid. 3 is valid if omega 0 is omega 0 square minus omega square is different from 0. If it is close to 0, you know that when denominator is close to 0, this term is very high value. The amplitude, this is total amplitude. This amplitude will be very high. So if omega 0 square minus omega square is close to 0, this term, the last term, then the system will blow up or collapse. Okay, and that happened actually. That Tacoma Narrow Bridge that happened in 1940 when they have constructed, they did not calculate properly what is the natural frequency for that system and what is the initial frequency or the frequency it is due to wind. If you see that video, heavy wind is flowing in that particular area. So that gives us that omega, and omega 0 is dependent on the mass and that spring constant. So K by M. So those matches. That's why after vibrating, it is collapsed. Okay. So more detail you may find. So only the last part. What I have given the title. So the last part is RLC circuit. You can see that. Okay, what is the RLC circuit? We know that, everybody knows that. If I put one resistance, one inductor, and one capacitor in a series, then the resistance is R, inductance is L, and capacitance is C. Then the equation, if I model this, so if it is the external force is the EMF, electromotive force, then the model will be L, the current is I, means the differentiation of I, L times I dash plus R times I, the current. That is by Kirchhoff's current law, the total voltage, the Kirchhoff's voltage law, the total voltage will be 1 by C, that is the reciprocal of the capacitance, into charge will be equal to total force, that is Et. And we know that, It equal to Q dash T. So rate of change of charge is current. Okay. So this implies I dash T will be Q double dash T. So therefore, this equation, fourth equation, can be written as, after dividing with L everywhere, so that will be Q double dash plus R by L Q dash plus 1 by LC Q equal to 1 by L Et. So again, it looks like exactly same as the governing equation for spring mass system. Hence, the solution will be the same way. If we solve, that will give us the solution. Once I get the Q, I can replace here to get the current flow. Okay, so this is the idea why actually RLC circuit is important, because many times when you are measuring the, or when you are modeling the spring mass system, because spring mass system is more useful. Means RLC circuit is also useful. What I'm trying to tell, suppose you are doing some construction, anything, then you are actually, you have to find, it should not happen, that resonance should not happen. So in that way, you have to measure it, all these parameters perfectly, and measuring those spring mass system is very, very difficult. So, but RLC circuit is very easy comparatively, less cost, and more accurate result you will get through RLC circuit. So, better to solve first RLC circuit with the same parameter as your spring mass system, and you no need to solve that spring mass system. That solution will exactly happen. So you know that here your charge is equivalent to the displacement there, your velocity, sorry, your current is equivalent to the velocity there, and your driving force, that is EMF, is FT there. Then your mass is, means your inductance is mass, inductance L is equivalent to mass there. Okay. Then your damping means resistance is same as resistance R is equivalent to damping constant B. Okay. So, and the spring constant is equivalent to the reciprocal of, so 1 by C is reciprocal to the spring constant K. Okay. So if we model like this, we can easily solve this system, second order differential equation, very easily, and we can get what exactly the current. So that means uh, what exactly the charge. That means we are getting the displacement exactly for the spring mass system. So with this, I would like to end my lecture. Tripathi sir.
Thank you, sir.
So any question or any suggestion?
Let's invite some question from our audience.
Okay, fine. So shall I stop the sharing?
Yes, sir.
Okay, thank you. I think I finished as per the schedule, correct?
Yes, sir. There is some interactive session. If there are some question, we will answer later.
Okay, sure, sure. Not an issue.
So thank you very much, sir, for your fantastic presentation. You are fantastically correlate the mechanics with the electricity. It is purely new and very, very helpful for not only our UG but also PG and research scholars. You are focusing the damping, over damping, critical damping, etc. And basically your focus on resonance, the concept of resonance, very, very useful. Sir, I have recapitulated something that in your Napoleon era, while the troops are marching through the
Yes,
wooden bridge, it was collapsed
exactly.
due to resonance. And after that, the troops are advised to stop marching while passing through a bridge. I hope this is the application of resonance, sir.
Exactly, exactly. Actually,
Sir,
no video for that particular march. That's why. But this Tacoma Bridge, narrow bridge, has the video. That's why I put that.
yes, sir. Yes, sir. I recapitulate it.
Yes.
And how the very, very the tricks for solving the problems in electricity chapter, that you have correlate the current with the velocity, EMF with the force, inductance with the mass, resistance with the damping constant. It is very, very useful for from starting to end. That is from plus to career, plus UG, PG as well as stream. So thank you very much, sir, for your valuable presentation.
Thank you, thank you. I'll share, if you need. I'll share this slide.
Yes, sir. Yes, sir. Sure, sir.
Sure. Thank you.
Next, we'll start our second session. In the second session, we'll see the Internet of Things and its use. We'll see that it is now the central research area in the field of electronics and its adjacent dreams. Large connectivity, smartphones, portable devices, and many more. The use of Internet of Things, that means in a single slide, you can say that the past, ages, the Internet is used by the human beings only. But nowadays, how this Internet is used in a non-living things. That is one mobile phone to tower, mobile phone to your mall, and here starting in our home we can detect the exact position of the moving train. How it is possible? So this will total focused in our second session, and now I will request to our speaker for the second session, Dr. Umakant Nanda, to deliver, to present his valuable presentation. Dr. Nanda sir, please.
Thank you, sir. Thank you for welcoming me for this session. And very much good afternoon to all of the students, my dear faculty members, and the professors, and the external speaker. So here I am going to deliver a talk on Internet of Things and its use in our society. Am I audible, sir?
Yes, sir.
Okay. Thank you. Sir, is the screen visible?
Hello?
Is the screen visible?
Yes, sir. It's clearly visible.
Okay, thank you, sir. So, Internet of Things. So, in this picture, all of you can see what are there. So, in our daily day-to-day life, what we use nowadays, it is not in manual mode. So nowadays, everything is going in on the wave. So we will clap, the lights will on. We will just do something in our mobile. The something will be happening in a very much distance area. So you can see everything: light, fan, the aeroplane, the vehicle, the mobile phone, all are connected. All are connected. There is a person who is sleeping. That means he is in bed and he is in hospital. So he is also connected. So somehow all the people and all the devices are connected together. So in our next era of technology, we will see that only devices will be connected. People will be out of the picture. So only the devices will be connected. They will talk to each other. No need to interfere in them. But that will have some advantages, but that may also will create some problems. So we'll see both of them, and definitely it is a boon to the human beings, and we are saving so much of time because of this, and we are getting so much of flexibility, and our life is getting easier. Okay, so we'll see so many examples, so many applications, and what we can do with the Internet of Things. So these are my outlines. First, we'll see what is Internet of Things, as it is very much new to you, this particular word, as per I know. So then we'll see growth of Internet of Things, how it works. Then what are the future perspectives, knowledge management, future of IoT, potential of IoT. So many applications we will see. Then we'll see the challenges which we will face or we are facing because of IoT. Then criticism. Criticism. People are also criticizing the IoT, and some controversies are generated. Then references. So here in this slide, you can see what is IoT. Internet of Things, the first line you can see that internet connects all people. So all of you are connected by the internet. You are talking to your friend, your relatives, your father, mother, parents. So with the people you are connected, that is okay. But this is not the end. We are also connecting the things through the internet. Okay, so that's what it is called as Internet of Things. So Internet of People, Internet of Things. So internet is for people. It is doing so many things for people, and it is also doing so many things for things. Okay, non-living beings. So what are these? So in a particular Internet of Things system, the first component which is required, mostly 90 to 94% chance is there, mostly it is required, that is called as sensors. So what are the devices, other devices? The sensors, actuators, mobile phone which will transmit a signal, or it can process also. Sometimes it processes the data, transmits the signal. The electronic devices like the computers or the even mobile phone or the laptops, those are also needed. Sometimes tabs also are used. Then home appliances. So what we do and what we are intending to do, we are intending to control the home appliances like light, fan, TV, all those things. Okay, those can be controlled from a far distance, not inside your home. So that is called as home automation system. Okay, so not only these are some examples. So other examples are also there. We'll go through it. You can see in the picture there is a plant. So what to do with the plant? So think about that. Suppose you are there in your you are not there in your house for 1 month, but plants will be there. Can you save them? They will die. Can you save them? Yes, you can save them with the use of Internet of Things. Okay, so plants will get the water whenever it is needed. Plants will get the light whenever it is needed. Plants will get the sunlight, it is needed. Okay, so but it will not get whole the means whole day it will not get. It will get for some time the sunlight or the water. For some time it will be given to the plant, then the plant will be happy, it will not die. Okay, even if you are months away from your home, so plants can be saved. Okay, then definitely your mobile phone or the phones, that phone can be connected, and by the use of land phone or the mobile phone you can operate your lights and fans inside your home. Then the factory, you can see the factory is also can be connected, because it is inside the factory. You will see that a control room will be there, so it will connect, the room will connect all the sections of the factory all together. Okay, so there is one it is not human being, but it is a animal. So animal also can be connected to the Internet of Things. Okay, through internet. Then laptop, then the weather, you can see rain. So when the rain will come or something, when the heat will be there, and weather forecast, that is also can be done. Okay, so many things, so many applications will be there. Look at this picture. What is this? In 2003, means around 17 years back, how many devices were connected and how many people were there in our world? So the world population was 6.3 billion, whereas the devices which have been connected at that time in 2003 was only 500 million. Okay, so connected devices per person. Per person, how many devices are connected? Means one person was using how many devices which are connected to each other, means which are connected through the internet. Definitely in 2003, I think in 2004 or 5 more people used mobile phone in India, but abroad they were using. So mobile phones were one of the connected devices at that time. So per person one, or it is around 0.08, you can see per person 0.08 devices were there. Then it crossed the number of people, number of population, it crossed the population at this era, that is around 2006-7. The number of devices which are connected crossed the number of people in the world. Then you can see how it grows. In 2010, the number of devices which are connected and the number of population. Okay, so and the connected devices per person 1.84. 2015 3.47. 2020 now we are using around 6.6 or 7 devices per person which are connected through internet. I am not telling only devices which are connected through internet. You can see connected devices per person. So now you can think of yourself only. How many mobile phones you are having? One or two? Two mobile phones will be there. Laptop, one laptop will be there. Then tab. Some people will be having tab. Okay, and some people also will be having some other devices which are connected. Some internet was the smart watch people are having. Okay, in India only maximum people are having 2-3 devices connected, but abroad you will see, even if in India you will see in the metropolitan cities and other cities they are using 6 to 7 devices. Okay, so in abroad so many devices in even if you will see in the companies or factories, those you cannot count how many devices they are using. Okay, so 7 devices are the average which is connected through the internet in 2020. Okay, so that's what the growth of IoT, how much. So now we can target that connection of 7 billion of people and 7 trillion of things. So 7 billion will be the number of people in the world by 2030, but 7 trillion of things which will be connected through internet by 2030. So they will dominate, the things will dominate us. They will be connected through each other. 7 trillion things will be there. Okay, just think about that, how IoT is growing. So IoT is a very good area of research nowadays, and people are doing so many things. Wherever you will go, wherever you will see, IoT will be there. You will go to the mall, IoT will be there. You will go to the office, IoT will be there. Vehicle, IoT. So everything nowadays, the upper level vehicles are coming. So vehicle to vehicle communication will be there. Car to car communication will be there. Automotive car will be there, means the car will be driven automatically, no driver, nothing. So car will be collecting the data that how much distance another car or another vehicle is going, how much speed I should go for. Okay, so everything will be automatically. The research is going on, and definitely they will be succeed in that, and the automatic cars will be coming and playing in the road. Okay, so what is that we are getting from it? That change is the only thing permanent in this world. So everything is changing in this world day by day, everything is changing. So that is the only permanent thing in this world. Then comes what are the 4 layers of model of IoT. So you can see this picture. So the first line, it is the application. So where IoT can be applicable. Smart logistic. What do you mean by logistic? So things which can be transferred from one place to another place. Your father is transferred from Nayagarh to Bhubaneswar, or Bhubaneswar to Delhi. So your things, your home appliances will be also transferred to another place. So can you track that? You are tracking definitely. Your courier service, you are tracking where my courier service is there, where Amazon from Amazon I have purchased something, where it is now. So everything that is also through IoT only. Then comes smart grid. So high voltage smart grid appliances, there also we are using the IoT. So where the connection failure is there, so those things you can see, these wires will be from so much distance, it will be there. So where the connection has broken, that also will be detected. Which tower is not working, that also will be detected. So this is another application. Then green building, that is also coming under the home appliances, can be controlled by a distance. Okay, and what I was telling, above the green building you can see some plants are there. So those plants also, without going to the plants, we can control their they will also move from one place to another place to get the sunlight. Okay, then smart transport. Smart transport means you can see one vehicle to another vehicle, what is the distance, that also can be detected. Smart transport, it is the parking of the vehicles, that is also coming under this smart transport. In smart cities you will not find a parking area near big bazaar. so much of rush is there. I cannot park my car. So where should I park? What is the nearest distance where I can park my car? That also will be known to us through IoT. Then environment monitor. So that what is the environment will be happening, what is the forecast, weather forecast, and where, even if you will see that the soil, where the soil is of what type, the humidity and the temperature of the environment, how it is. So in which environment which tree can be growing easily, so that also will be known to the farmers. So farmers, by sitting in their home, they can also know about the soil and the weather of a particular area. Then they will go and plant their trees or crops like that. But these are the applications. So these are the applications. Then comes how these applications can be fulfilled. How these applications can be fulfilled. So before this application, who sends the data to the people is called as information processing. So here you can see data center is there, which will keep the information. So much of data will be there, which will be stored in some safe place, in some memory. So these are the servers, big servers are there. They will collect the data and they will process the data. They will collect and process the data. So this is called as data center. Search engine. So your best search engine is your Google. So how you are finding the data? Already in the Google server, those data have been fed. So that's what you are doing. You are just searching. That is one type of data mining also. So Google, search engine is also one type of data mining. So data mining means you are just digging the Google that to get some information about something. You are giving the keyword and you are getting the information. So that is also coming under this IoT. Then also human decision, smart decision are needed. Okay, it is not like that you are searching something and you are getting something else. So your decision also should be there, that it is not the proper data. Okay, I will search again. Then the main thing here you can see information security. So in Google, everything you will get. So something will be there that will not be shown to you. That is called as secured. Like some information will be there about the army of some country or something. That will be there, but it will not be shared to you, to the general people. Okay. So sometimes you might have seen that you are not authorized to see this video, you are not authorized to see this information. So that is called as security. Security also should be provided sometimes, otherwise it will be horrible. So then, okay, you can see this environment is there, smart environment, smart transport, smart city, buildings, green buildings, logistics. They are sending the data to the data center. Okay, and in server it is stored. But how they will send? They will send through the network construction. So different types of networks are there. So communication networks will be there. This is called as wide area network, WAN, wide area network. That means the area between one tower to another tower will be the distance will be very much high. Okay. So then this is WWAN. That means wireless wide area network. Similarly, wireless metropolitan area network. So these towers are for the only one city, one metropolitan city. They will communicate to each other. So definitely some towers are needed to communicate, your mobile phone towers like that. Then internet connection should be there. Otherwise, nothing can be possible. So no one can get some data without the internet. Okay. So like this local area network, wireless local area network, and the network, mainly the network, the communication network is needed. Okay. And then comes the next layer, that is called as sensing and identification. So what do you need to send? You need to sense the soil moisture level of the soil, temperature of the room. Okay. So whether the room is getting some smoke, whether any fire exists in the room. Okay. And what is the distance between one vehicle to another vehicle? It has to be sensed. So for that, different sensors will be there. They will give the data. Actually, they will give the data. They will send the data through the network to the data center or some servers with some security. Then it will be used in these applications. Okay, so I have told you from the top to down, from the application to the sensors, from sensors to the applications. So both the ways we have seen. These are called as 4 layers of IoT. So the IoT as the network of networks. Network of networks. What do you mean by that? You can see transport is a network. Education is a network. So you can see like the Byju's is there, and education sector, like some coding sector is there, coding things they are teaching something, they are doing. In business, your stock market information, that is there. Home, from your home, the all the information, like your fan or light, whether it is working or not, whether it is on or it is off. Information about the soil, that is the earth. Okay, and other things, so many things are there. So they are connected through a network. You can see, connected through a network. So these are called as individual networks. So transport to energy, energy to business, education to business, so all are connected through individual networks. But they are also connected through a outer network, that is called as the internet or internet of things. Through internet they will be connected. So internet IoT is also called as network of networks, and everything should be connected, but with security. So the networks connected with added security, analytics, and management capabilities. So how IoT works? First of all, you can see one block is there, that is called as RFID, radio frequency detection. Okay, so it identify and track the data of things. So you might have seen in the malls. In the malls, you are purchasing something, they will be having one RFID reader, like one gun type structure. They will click on your whatever you are purchasing. There will be a barcode. So that is called as RFID detection. And from that they will get the information about the cost. What is the cost? They will directly get the information in their systems. So no need to search about the cost, and data malfunction will be there, and some wrong data they may get. But RFID reader will give the correct data, and in easier way. Then sensors, as I have told you, different sensors are there for different purposes. Then smart tech, to enhance the power of the network by developing processing capabilities. So see, everything and anything happens, it needs energy, it needs power. Okay, so how much power consumption is happening, that also should be reduced. Otherwise we are limited with power. So we cannot go very much high power consumption, that will be costing us too much. Then nanotech, this is another device, and this you can see we are using the blood pressure sensor, like cholesterol sensor. These are these will be inserted to our body, and inside our body what happens, small devices, what happens inside our body, what is the cholesterol level, what is the you can see another thing, blood pressure monitor, that also will be detected if it will be inserted in our body. Same IoT system only, but very small it is. And glucometer, you might have seen glucometer, one small chip will be there. We are just putting our blood on that chip, and it is detecting what is the sugar level of our blood. So that is coming under this nanotech, that is also IoT system. So what is comes under knowledge management. So you can see, first of all we should get the data. Then from that data we will know that who, what, where, and when questions. So who is doing what, where he is doing, and when anything is going to happen. Then from that we will get the knowledge. Okay, and out of that knowledge we will get the understanding that whether this is a particular knowledge which we want, or something else we want. Okay, then comes wisdom, that is the evaluated understanding. among this all. So this is very much benefit to our humanity. The more data for that purpose, the data you can see in the base, the more data that is created, the better understanding and wisdom people can obtain. Not only people, the IoT systems also, if the data is very high, then the accurate result it will get. Suppose I will give you one example, like we are testing, we are sensing the moisture of a soil. Okay, so there is a big field available. So in one area soil moisture will be something, in another area of that field soil moisture will be something, in another area it will be different. Okay, so we will take 100 number of data and we will take the average of that. That will give you a particular result. Then we will, if one person is taking 100 number of data or 100 times he is testing, then he will get one result. If another person is testing with 1,000 of data and he is taking another average, so definitely the 1,000 data who was taken, he will get the particular actual data. Okay, so that's why the more data collection, the more accurate result information. What will be the future of IoT? You can't imagine. You can't imagine what happens when 50 billion of machines become connected. So everywhere, from the homes, from the electricity area, from the shipment, means this is the courier services, hospitals, okay, medical devices, those will be connected. Okay, the mobile towers. Okay, then smart grids will be there, factories will be there. Okay, logistic, that is also there. So the in future, when this many number of machines will be connected, then the operational technology, OT, that is called as operational technology, will be visualized. That anybody can, by sitting in his home, he can visualize everything. No need to go anywhere. We will be sitting in our home, we will be eating, we will be sitting, and everything we will control. Not only we will see, we will control everything. And in that, the analytics means whatever the analysis we are going to do, that can be predictive. The productivity of the companies or the industries will be increased definitely, because one person is sitting in his home and doing something, and another person is going traveling 1 hour or 2 hours of journey, and he is doing something. The productivity will vary. Definitely the productivity where one person is sitting in his home will be better. Machines are self-healing and automated. So machines will be talking to each other. So one computer will be talking to each other. You no need to interfere with them. So they will be talking to each other and they will be healing themselves. If machine is having some trouble, it will be healed automatically. And monitoring and maintenance will be mobilized. That means you might have seen that in a far distance, one person will be there. He is a technician. He will, even if the doctor, he is at Delhi. Nowadays, from Delhi or from US also, one doctor will see you and he will, nowadays they are doing the operations also. Some doctors will be there in our Bhubaneswar, but one person will be there who is a very renowned doctor in US. He can control everything. The operation will be done in Bhubaneswar. So from a big distance also, it can be monitored. Everything can be monitored and maintained. So what is the conclusion we are getting from this? The sky has no limit. It's only the beginning of IoT. So what IoT does, it unlocks the massive potential. So everything is there, but we cannot do. The IoT can do. Okay. So it improves the performance, the productivity, and reduces the cost. Definitely in the traveling and all, the cost will be reduced. Create innovative services. So definitely new things will be coming, and it will streamline the revenue. Technology roadmap of IoT. As the time progresses, you can see from 2000 to 2020. So what was there in 2000 and what is there in 2020 and what will be coming next, that you can see. in 2000, what the sensors we are having? Very limited amount of sensors were there. So RFID sensor was there, which was in 2000 it was available. Even not in India, in other countries it was available. RFID was detected and the cost of a particular product can be determined. Okay. And then comes 2010. In 2010, the surveillance system, like your cameras, the CCTV cameras, so security, for the security purpose it was used. In healthcare, the IoT was used. Okay. Transport, it was used. Even not in India, in other countries they were using. Food safety and document management can be done in 2010. Now in 2020, so many things are happening with them. Other so many things are happening, like tele operations and telepresence. Like just now I have told you, one doctor is there in US, he can operate. The patient is there in Bhubaneswar. So ability to monitor and control distance objects. Now you can see in distance learning system also. In distance learning system, some teacher will be there anywhere else. In this pandemic time also, we are getting the help from the teachers who are far from us, but they are teaching us, and we are getting the benefit. So that is also happening nowadays. So there is no limit. As I have told you, there is no limit for this IoT. So, so many things can be connected with each other. The ultimate goal of the IoT is to automate the human life. Now we'll come to the some examples where you can see the buildings and home automation systems. Like already I have told you, the fans, lights will be controlled by a distance. Suppose I have forgot something to off the fan, and I have come to the office, then from mobile phone I can switch off my fan. In manufacturing sector, that is also very much useful. Medical and healthcare system, just now I have told you, the doctor can operate. And healthcare system, the blood pressure, the sugar can be checked, and that can be used inside our body also to get the cholesterol level. Definitely the media, in media IoT is very much used. Environmental monitoring, the weather condition monitoring can be done. Infrastructure management, energy management. So I'll give you one example. IoT can do like this. So in your village, many people are hooking and bypassing the electricity, and it is a very high loss to our electricity board of Odisha, of India, everywhere. And everywhere it is happening also. Can we control that? Yes, we can control that with the help of IoT. What we will do, we will just what is the power consumption of that house, we will put a meter. However we are getting that meter, the reading, and actual current how much is passing to that house, we will put a meter in the pole from where the wire is going inside the house. So if they are bypassing, definitely it will be detected. In fact, that project, my students, my second year BTech students, they have done that project, and they have done it successfully. So that is energy management. There also we can use the IoT. Transportation, like vehicle to vehicle communication, that will be there. Inside the vehicle, so many things will be there. Inside our cars, so many things are there which can be controlled through IoT. The parking system also can be done through IoT. Better quality of life for elderly, and so many things. So many examples will be coming. So you think about something, definitely it can be done with the help of IoT. Diversified applications starting from the home, from the consumers, transport, mobility, healthcare, body, and buildings, infrastructure, cities. So everywhere you will see. So smart cities, we will see the IoT. You can see the smart parking. So actually it is not required. This much of parking space control is not required, but smart parking is required. As I have told you, if you are going to Bhubaneswar and you don't know where to park my vehicle, something should be there. Some app will be there in your mobile phone, and it will show you where the available place is there to park your car near to your destination. Suppose you are going to Big Bazaar, near Big Bazaar, so many vehicles are parked and you are not having space. So where it is where the space is available. The GPS machine will tell you that this place it is available for parking. You go to that. Even it can show the parking cost also. So by when you are going to the place in the on the way only, you can get the information. Here the parking place is available. So that is also a very much advantage for the human being. So that is called a smart parking. Garbage collection. You might not have thought like this. So garbage collection, you can see in cities like Bhubaneswar, so much garbage will be collected. In the morning time, big trucks will be there, which will be coming to one building to another building. So many buildings will be there, so many apartments will be there. Okay, so in our apartments, the garbage collections have been already done by the sweepers and other people, garbage collectors. So they have already collected the garbages from the houses. Now the garbage collector, this vehicle, will get the information that in which apartment, the garbage containers have been filled. Okay, have been filled. So to that apartment it will go first. Even in some apartment there will be no people, but still it is going. But through the IoT, it will know that in this apartment garbage bag is not filled. I will not go there. Okay, so it will save his fuel and the time also. Okay, so the garbage trucks will save the fuel, the time and the traffic, and you will see that some person is going behind him. He will be feeling terrible, like with the smell. Okay, so everywhere it will not go. The places where it is required, it will go. Some sensors will be there that the sensors will tell here the sensor is there in the garbage bags, okay, garbage containers. Sensors will tell that the garbage container is filled. Then only the truck will go there. Otherwise, it will not go. Even the garbage collector who is collecting from our house. In our house, the garbage container also will be having the sensor, and it will tell him that in this house the garbage container has filled. I will go to there and collect. So that will save the time, the fuel of the vehicle and everything. Funny thing, you can see cow also will be having one sensor. So nowadays in villages, you might have seen that in the ear one tag will be there. On the ear it will be tagged here, and the number will be written there. But in IoT system, what we can do, there will be one antenna here and sensor will be here. This sensor will sense the particular place of the cow where he is. Sometimes the cow will be roaming here and there, but no need to bother about that. In our mobile, it can be seen that where the cow is available. We should not go behind him or her. Okay, so and what is the health condition of the cow, whether it is good or not, whether he is feeling she is feeling better or not. Okay, what is the health condition, that also can be observed. As cows, water pipes, people, and even shoes, trees, and animals become connected to IoT, the world has the potential to become a better place through IoT. With a trillion sensors embedded, connected in the environment, are connected by computing systems, software, and services. So there is a thought by Peter Hartwell, senior researcher from HP. He told that it will be possible to hear the heartbeat of the earth impacting human interaction with the globe as profoundly as the internet has evolutionized communication. So the IoT will be impacting our world that much. That world will be just beating like IoT everywhere IoT, it will be there. So it will happen. So how much more IoT can do is it is only left to you that you imagine how much it can do. You can see here how much time I have slept in last night. That can be seen in a smartwatch. I will wear that watch. Some of you might have using this watch. So how much time I have slept, when I have woke up, how much time I woke up, I have not slept, how much time, everything can be done. What is the calorie level of our body, that also can be determined. How many steps I have walked in the morning, that also can be determined by this smartwatch. So this is also IoT system. Come to this, this is a mall. You can see in this mall, so many, this is actually a grocery mall. You can see so many bottles are there. Okay, this person is going and taking some bottle. Okay, when one bottle has been taken, that place is empty. Okay, so some another bottle should be coming here and placed here. In big malls, one person cannot go and see everywhere where bottle is not available. But if this row will tell that, this row, this shelf will tell to the counter of the mall that this place is empty, put some bottle, how advantageous that will be. It will save the time, and it will suppose this total row is empty and bottle is not available, this particular product is not available, and that person is going to purchase that product. He will not see that product and he will go. Okay, so the productivity also increases in that way. Whether a particular product is fine, means it is not having any faulty inside it, it is not faulty, that also will be detected. When entering the doors, the scanners will identify the tags on her clothing. So a customer entering the door can be known what is the name of that customer and what is the identity. Okay, that will be known by the mall automatically. So no need to ask her, or no need to. Now in the pandemic time, you might have seen that when you are entering into a school or into a mall, they will write your name, that what is your name, because some risk is there always. So they will write your name, but no need to write. By scanning her or his cloth, it can be known. Some tag will be there, some RFID tag will be there definitely. So you can see here, it is scanned. She is scanned. Okay. So when paying for the goods, the microchip of the credit card will communicate with the checkout reader. Okay, so see, microchip of the credit card, that means credit card will be there in your pocket. No need to remove from the pocket. Inside the pocket it will be there, but the reader will read it, and automatically the money will be deducted from the credit card. When moving the goods, the reader will tell the staff to put a new one. That I have already told you. If the goods have been taken, so put a new one. It will be automatically told to the staff. Now we'll see. So many things I have told, so many fancy things. You are thinking this is fancy, but it is not fancy. It is happening. Okay, and it is happening because of IoT systems and because of engineers and scientists who are doing their day-night job to make it fulfill. Before 10 years, it was just like a dream. Something happening nowadays, it is like a dream before 10 years, but now it is happening. But we'll see some small examples for the beginners like you. So what is the small examples we can see? What is there which is doing something like this, something great like this? This is a board called as Arduino board, Arduino, Arduino board. This is called as a particular microcontroller. And what is inside this? It is the job of an engineer who will, if you are in your future, if you are going to be an engineer, you will learn what is there inside this. Okay, I'm not going inside this. What it can do, that I will tell you. There is a sensor called as gas sensor. So MQ5, it is a gas sensor. We will put it in the roof of a house or at the top of a room. Okay, this is called as a gas sensor. In a lift, we can put it. So it will sense the gas. If anybody is smoking cigarette or something happening, some gas is coming. So that will be detected by this sensor. Immediately, it will give some signal to this board, Arduino board. Okay, and when it will be giving the signal to the Arduino board will process it and give a signal to this LED and a buzzer. So LED will glow at the same time, the buzzer will buzz. so much sound will be coming, that the sensor has detected some gas. Okay, and it can also send the signal to a mobile phone. The mobile phone will be with the house owner. Okay, he will see that something is happening, some the gas sensor has sensed something. Though the house is closed, he will get the message and immediately he will come to the house and switch off something. If it is happening, some short circuiting or something is happening, he can save his house. Okay, and there is the internet which will help the signal to come from this system to this mobile phone. So this is a thing, mobile phone is a thing, this is internet. Through internet it will be coming to the phone and it will be detected here. So this is about the gas sensor, what can be done with this. Then comes a temperature and humidity sensor. Like I have told you that the weather condition, what is the temperature and what is the humidity of a particular area, that can be sensed by this DHT11. This is humidity and temperature sensor, which can be connected through the same Arduino board you can see. Okay, small experiment. These experiments you can do in your +2 level also. This board costs you around 500 something, 500-600, and these sensors will be, all the sensor will be coming under 200-300, means 1000 rupees you can do it, a small project you can do. Okay, so definitely you can do, but it will sense and it will give it to the this board. And where you will get the information, you will get the, this board also can be connected to your PC in your laptop. Okay, so or else you can send that information to a mobile phone, to an app or a mobile phone. You can get the message or something, some data, we can see it. Okay, so what is the temperature and humidity of the weather, that also you can see through this temperature and humidity sensor. Then comes IR sensor for distance measurement. Very simple it is. This sensor will be placed in some place, and what is the distance between this sensor and a particular object. Okay, so suppose you are having a robot. Mainly IR sensor is used in the robot. IR sensor and ultrasonic sensors will be used in the robot. So robot will go automatically. If it is facing some obstacle like a wall or something, it will be stopped there, it will change its direction. Okay, so at that place IR sensor will be used. This is required for measurement of the distance from a particular product or a robot, like that. Similarly, the ultrasonic sensor also used for distance measurement. So here ultrasonic sensor is there, like a, you can see like a eye structure, it is there. It is called as ultrasonic sensor, connected to your Arduino board, and what is the distance can be displayed on this display device also. Okay, because means depending on our requirement, we can use this particular display device or not. This is called as a 16:2, 16 columns, 2 rows sensor display device. So it can display. Okay, what is the distance between this particular system and other device. So ultrasonic sensor is more powerful than IR sensor. So more powerful, and this will give you the range of the distance is more for this particular sensor. Okay, so so many examples we have seen. Now we'll go to the challenges of IoT. So at present, IoT is facing the challenge as scalability. So we need so much of IoT systems, but still we are not achieving that standardization. So one board I have told you just now, Arduino board. That board is used by our students, my students, that board they are using, but in other countries, other institutions, they will use some other board. Can we make some standard that only this board will be used for the IoT systems? Interportability, like this board is giving some data, another board is giving some another data. Can we portable, or can you get the portability of those two devices, two boards? Discover of new things in the IoT, that is also a challenge. Software complexibility. So you can see we are not using only the hardware. You mind it, we are not using only the hardware, we are writing some codes. Okay, so the software and the code the language which you are using. You might have heard about the language like Python, like C programming, okay, embedded C programming. So those programmings, we have to write the programs, then only it will work. So not only the hardware, the software is also needed, and the complexity should be reduced so that it can be written by a person who knows very little about this. The power supply, definitely IoT system is there, means power supply is required, but can we minimize it? Short range communication, interaction and short range communication. Short range communication also can be done, like with the Bluetooth and the infrared also communication can be done, but still it is a challenge. Wireless communication. So in all the areas, wireless communication is not possible. So like villages and rural areas, it may not be possible. So that is also a challenge in mainly in India. Fault tolerance, and fault tolerance means a sensor is working since so many days. So whether it is working now or not, okay. So it should work for more days. It should last for more days. Then so many criticisms are also there, controversies are also there. Definitely something you are doing means controversies will be there. So what are those? The people, they observe that they will having doubt that whether it promises the computing revolution, this what it promises it will get or not, or it is getting or not actually. The privacy, main thing, the privacy. So everything is having the privacy or not, means if I am getting some data, whether other person is also getting that data or not, because you see mobile phone, China mobile phones are there. That is the main point of discussion before 2-3 months or 4 months. So China mobiles we should use or not, because IoT device means mobile is means 90% mobile is used, okay. So whether we are having that much privacy or not, security interrelated with the privacy, okay. Autonomy and control. So we should have the control of everything, like our mobile phone, our systems, the software which we are using. Social control, so it can be used in a wrong way also, so that we have to control it. Political manipulation, like in the voting machines, like you can see the EVM machines. So you know it, EVM machines, how it can be misused. So that should not be done. And design is a challenge for the engineers. Environmental impact, so what is the frequency we are using in the mobile phones? So if IoT is there, means so much of mobile phones will be used, okay. So the signal which is generated of high frequency, so it will impact definitely to our environment, so that should be controlled. Influences the human being for moral decision making. So if IoT will do everything, what the human being will do? So you can just observe that in your mobile phone the numbers are there, mobile numbers will be there of your relative and friends. So you are not remembering. In our days when we are not using mobile phones, that at that time we are remembering at least 8 to 10 numbers. Now I don't know about my brother's number or sister number. It is there in my mobile phone. I forgot. I forget everything. Okay. So that also is happening. IoT is doing everything. I am not going to do anything. So in summary, Internet of Things, what we got is above the sea. You can see this much we got, and what we have not got, but we can get it is this much. So iceberg has been shown to you. Just a tip of that iceberg we have already achieved, but how much we have to achieve? This much. So when you will be one engineer, if you are going through that line, you can go for this much of, so much of research can be done on this area. So with this, I am concluding my talk. These are the references which I have followed. Thank you.
Thank you. Thank you, Dr. Nanda, very much. I was astonished. Once I was seen through a TV serial that God or goddess come from heaven and show their hands like this. Some focus will you come to earth and do everything. I hope this is happening here. This surgeon at USA can do operation here. The car, everything you have present, you are focused in your talk. It is very, very fantastic and very useful nowadays. You have focusing everything, the 4 layers of IoT. It is very, very important. And I hope the world is going changing in a faster way.
It is happening. It is happening. You see now
So
in
very
our
much
institute, just now one project, one group of students they are doing the distance between one person to another person who is infected with COVID. So they are doing first they will detect the temperature
yeah.
of that person. So if it is temperature detection will be there for a person, and what is the proximity means what is the distance between that person to another person who is having this. I like your Arogya Setu app. Same thing it is doing. They are doing now here in our institute.
Okay, okay. I hope the man became do everything just like the God without touching. Get information at home. The whole world is within his pocket. Thank you, Dr. Nanda, for your nice
Welcome.
talk.
So one query is there, what is difference between
We will have
digitization and automation? See, digitization is the first step. After that, automation happens. So automation happens through the systems, through the computers, and computers need the digital signals, not the analog signals. What is the difference between digital and analog? The sensors, what the signals the sensors will give. Suppose the temperature sensor is there. Temperature sensor will give an analog signal, not a digital signal. Temperature sensor will give an analog signal like a voltage signal only. In your electrical circuit you might have learned voltage signal. The voltage signal is having some maximum amplitude. Okay, so the amplitude detects the temperature. Suppose the amplitude will detecting the temperature, how much temperature of the room it will detect. But that signal is an analog signal which cannot be processed or transmitted through the mobile phone, cannot be processed inside our computer or laptop or any mobile phone devices. For that purpose, I need to convert it to a digital signal. Okay, so one converter is there that is called as analog to digital converter. That converter chip or IC will convert the signal from analog form to digital form. That is called as digitization or digitalization. Then after that, the computer will process the digital signal and transmit the signal to any other computer or other device. Okay, and we can also control the like that we can control the temperature also. We can get the information about the temperature. That is called as automation. So digitization and automation, they will go hand in hand. First digitization has to occur for automation.
We will invite some more questions from our audience in this the interaction session. And after the interaction session, we will see the vote of thanks by Amarendra sir. Let's invite him to our meeting. Perhaps he is in. Amarendra sir. He's muted his mic. First unmute the mics.
He has to unmute himself.
Sorry, sir. Honorable Patron and Principal of my college, BS College Daspala, Professor Sridhar Ratha, Honorable guests of the youth spirit of Daspala, a promising and flourishing leader of Odisha, our beloved MLA, Mr. Ramesh Chandra Behera, respected speaker of topic, Mass spring damping to LCR Circuit, Senior Assistant Professor Dr. Saroj Kumar Das, the most expert speaker of the topic Internet of Things, Associate Professor Dr. Umakant Nanda, the convener and the real organizer of this national webinar, the team leader of my Department of Physics, Dr. Umakant Tripathi, and participants, all the participants, including the Axian students. I have the pleasure at this concluding scene utter a line or two on this auspicious and a memorable occasion. Truly, I am thankful to the speakers, honorable guests, our patron and convener also. At the same time, I have my divine wishes for the blooming buds, our students who are really from this webinar. Such webinar would definitely enrich them from knowledge point of view. I offer my unconditional vote of thanks to the learned speakers of the day. Finally, at last, I have no hesitation to admit that all the participants have their contribution to make this webinar a grand success. We have tried our best to make this webinar impressive and colorful. Still then, there might have some problem or teeny mistakes in this arrangement. I must appeal and request all of you not to mind it. Finally, thankful to for your cooperation, coordination, inspiration, and wishes in next coming days. Thank you.
Thank you, Amarendra sir. I, with my folding hand, request that this is the end session of this webinar. Thank you very much.
Thank you.
Thank you, sir. Thank you all.
Thank you.